hope it is recording. Yeah. Okay. So this is there are seven such rows in this decision tree, and first is the first person loves Titanic, loves Lord of the Rings. Then his or her age is 7, but he doesn't love Harry Potter. So these are so you read this table in this format, there are 7 different users, and you know whether each user loves Titanic or loves Lord of the Rings, and you know the age of the user, and also know whether the user loves or does not love Harry Potter. So depending on all these, you want to build up a decision tree to find out whether when a new user comes and you take the feedback whether he or she loves Titanic, loves or does not love Lord of the Rings, or and his or her age, whether he or she will love Harry Potter or not. So that is the premise of the problem that I'll be discussing. Okay, so decision trees is so now we'll learn how to build this simple tree. This is a very simple tree because there are only 3 features, and it's and whether he or she loves or does not love Harry Potter is the question that we are trying to answer. So the first question is, how do we decide on the root node? So decision tree is like when you select a root node, you will have a true false sort of a thing. So so it's like when depending on the value of the root node, you will either do a set of things, or if it doesn't or depending on the other value, you will do another set of things. So it will become clearer as I go along the way. So the first question is how to decide on the root node. You have 3 features here: loves Titanic, loves Lord of the Rings, and age. So how do you so you have three such columns, and so you need to decide which of the column you should start first. Should we focus on whether the user loves Titanic, loves Lord of the Rings, or should we start with the age of the user in the first place? So how do we decide that? Let's look at a simple example. Since the first column itself is loves Titanic, so we take loves Titanic and we take a true false decision. So this is where you are taking the decision. You are trying to how should I say it, you are trying to split the data set into 2 halves, whether the user, or depending on whether the user loves or does not love Titanic. So let's say the user loves Titanic, and that condition becomes true. That comes to the left of your the tree, and in case when the user doesn't love Titanic, it comes to the right of your right of the tree. So loves Titanic, you come true, you take the true value of it, and loves Harry Potter. Just a minute, people are still in. Okay. So when somebody loves Titanic and loves Harry Potter, you know that there are certain yes and no conditions there. So can somebody unmute and volunteer about how many yes should be there and how many no should be there? I am talking about the left block here.
4 yes and 4 no.
4 yes and 4 no. Okay. How did you get that?
The loves Titanic column has total 8 entries, 8 observations.
It has 7 observations.
7 observations, sorry. So 4 yes and 3 no.
No, the question is, you are okay, so this is the confusion that you are
yes
having.
And no. Yes and no. Only 2 branches will be there.
Correct.
True and false, true and false.
Correct. So loves Titanic, there can be true and false. So loves Titanic true means somebody entering. Okay. Loves Titanic true means you are already talking about yes in this column. Correct? Am I clear, or should I go through this once again?
Yeah, it's
No,
clear.
no, I got it.
Yeah. So
1 yes and 3 no.
Loves Titanic is 1 yes and 3 no. Okay, let me see. I don't know the answer. I have the answer in the next slide. So, and if it is false, then can somebody say? Somebody doesn't love Titanic but loves Harry Potter. How many cases are there?
2 yes, 1 no.
Yes, 1 no.
Okay, 2 yes, 1 no. and 3 no, 1 yes. Yes, so you are correct. Similarly, so likewise we have Love's Lord of the Rings. This is one column on which, now if we set love columns, Love's Titanic as a root node, then these are the next two branches that we get. Similarly, if we have Love's Lord of the Rings as the root node, then these are the two branches that we get. So let's say Love's Lord of the Rings, which means 1, 2, 3, 4. There are 4 such. The first row, the third row, the fourth and the fifth row are Love's Lord of the Rings, out of which there are 3 yes and 1 no, which is why you see yes 3 and 1 no. And similarly, you have Love's Lord of the Rings false, which is 1, the second row, the second last row, the sixth row and the seventh row, and all of them does not love Harry Potter. None of them loves the Harry Potter, so that means yes is 0 and no is 3. Am I clear up till this point? Anybody has any doubt?
No, sir.
Okay, good. Then okay, so now we have some more terminology, like if you see these if you see these 4 nodes that these 4 branches that I just that you guys helped me do, like there are 4 branches, right, out of which all of them, if you see, except this rightmost one, on the bottom rightmost one, all of them have some mixture of yes and no. Like this has yes 1 no 3, yes 2 no 1 and yes 3 no 1. Such nodes are called impure, or such leaves are called impure leaves, which is why because at this point you cannot take a decision. Why are they called impure? Because you cannot take a decision based on this leaf itself, because this leaf has 3 yes and 1 no, and all of them have similar sort of things. So these are called impure leaves. On the contrary, there is something called a pure leaf. So what is a pure leaf? A pure leaf is one where if you reach that leaf, you are absolutely certain about what that decision is, because you know that in your particular training set, if you come to this leaf, then there is no possibility of that person loving Harry Potter, and there is 100% possibility of that person disliking Harry Potter, which is why it is called pure leaf, and you can take a decision based on this leaf itself. So that is why this is called a pure leaf. So from the terminology of pure and impure, can somebody tell me so it is a question that is like the basis of decision trees, like should I aim for impure leaves or should I aim for pure leaves? What do you think?
Pure leaf.
Why?
Because it gives a clear message, yes or no.
Correct. So so that is why we aim for a pure leaf at every point, and therefore we need a measure of impurity that is there in a leaf. Okay, so how do we measure the impurity that is there in the leaf? There is something called entropy, which I think was covered yesterday by one of the TAs. So I will be talking about the other impurity measure, which is also very commonly used, and I think it is much more commonly used than entropy. So that is known as the Gini impurity. So what is the Gini impurity? If you for example, if you have C classes in a leaf, for example here you only have 2 classes. So if you have 2 classes in the leaf, each with a probability of PC. So here if you have 2 classes like yes and so here if you have 2 classes yes and no, you have the probability, you only look at that leaf, and the probability of yes is okay, what is the probability of yes in the top leftmost or the top left leaf?
25%.
25%.
1 by 4, correct? So that is the probability that we are talking about. So so you talk about that probability, and you talk about the probability of both the classes, you take the square of it and you subtract it from 1, that is the way Gini impurity is defined. So depending on your Gini impurity, we will see some examples, and we will see the examples of all these cases actually, and yeah, we will see the examples of all these 4 leaves, and we'll understand about how Gini impurity works. So basically Gini impurity, the higher Gini impurity is, the more impure that leaf is. That is basically the concept that we are talking about. Okay, so how to build one simple tree? Again, if I come back to this, Okay, so as I said, so we have loves Titanic and true. It's the same. It's basically the same leaves that I drew in the last slide. I've just copied them here. So let's say the loves Titanic. I've taken the decision of true, and that becomes loves Harry Potter. Yes, 1 and no is 3. So the Gini impurity index is 1 minus 1 by 4 whole square. Why 1 minus 1 by 4? Because that is the probability of yes, and 3 by 4 is the probability of no, and therefore Gini impurity becomes 0.375. Okay. Okay, can somebody tell me the Gini impurity? I don't need the value, just in these terms, like 1 minus 1 by 4 whole square minus 3 by 4 whole square. Can somebody tell me the Gini impurity of this particular leaf?
1 minus 1 by 2 square minus 1 by 4 square.
1 by 3. 1 by 3 whole square.
1 by 3 and 2 by 3 square.
2 by 3
1
whole
minus
square.
1 by 3 square, 1 minus 2
2 by 3
3
square. Correct. So the probability of yes in this particular branch is 2 by 3, and the probability of no in this particular branch is 1 by 1 plus 2, which is 1 by 3, which is why the Gini impurity index will become this 0.44, and the total Gini impurity will be at this particular stage you need to find out the total Gini impurity of these two nodes together. So if you see, there are 4 such training points on the left hand side and 3 training points on the right hand side out of the total of 7 points. So you take a weighted average of these two Gini impurities and add them up, like 4 by 7, which is this has total 4 points, so 4 by 7 into 0.375 plus 3, because it has 3 points, 3 by 7 into 0.44, which becomes 0.405. Okay, so without any calculation, can somebody tell me the Gini impurity of this particular node which is highlighted right now? The loves Lord of the Rings and false. What is the Gini impurity of this this particular branch?
0.
0. Why is it? Why did somebody? Because you see, this is 1 minus see, this is the probability, this is a Gini impurity, right? So yes has a probability of 0 in this case, and no has a probability of 1, which means that 1 minus 0 by 3 whole square minus 3 by 3 whole square equal to 0. So Gini impurity of this case, of this particular branch, is 0. Can somebody tell me intuitively why this is supposed to be the case? So why is this coming out to be 0? We saw it through the formula that it is coming out to be 0, but
It is a pure node.
Because it is a pure, because
Correct.
most of the
Exactly.
cases belongs to the
Correct. So whenever we reach a leaf which is pure, or whenever we reach a node which is pure, in that case the probability will all be given to one particular class, and probability of one particular class, of only one probable class being there, means the probability will be 1 and the Gini impurity will turn out to be 0. So basically this is a pure node, which is why the Gini impurity is turning out to be 0. And similarly, if you do the same calculation on the left hand side, on the left hand node, it will come out to be 0.375, and the total Gini impurity in this case is 0.214. Okay. Now the other, so we are done with Love's Titanic, which gave us 0.405, and we are done with Love's Lord of the Rings, which gave us 0.214 Gini impurity. Now the only other column that we are left with is age. Now for Love's Lord of the Rings and Love's Titanic, it was simple because it was all yes no questions, or yes no. So it was okay. So can somebody has unmuted themselves? Can you mute? Yeah, thank you. So now we are talking about a numerical feature, which is age. So how do we handle this numeric feature? To handle this numeric feature, the first thing that we'll need to do is, here I have already done it, is like you need to sort them according to the or in increasing order of their values. Like age is 7, 12, 18, 35, 38, 50, 83. You sort them accordingly, and you take the midpoint of all these values. Like you take a midpoint of 7 and 12, that comes out to be 9.5. You take the midpoint of 12 and 18, that comes out to be 15. take the midpoint of 18 and 35, that comes out to be 26.5, and so on. And the value that you are seeing on the right hand side is age less than 9.5, which is nothing but the midpoint of these value 7 and 12. So this midpoint is just it is just a convention. You can take any other values which lie between 7 and 12, you can do that, but this is just a convention, so I am following that. So the first question is age less than 9.5. So age less than 9.5, there is only one such candidate with the age of less than 9.5, and he or she doesn't love Harry Potter. So loves Harry Potter, yes becomes no, and yes becomes 0, and no becomes 1, and in which case Gini impurity is again 0, because we have all the probability mass is given to no in this case. Similarly, if we go to false, then we have the last 6 rows of this table, and there are 3 yes and 3 no. So yes is 3 and no is 3, in which case Gini impurity achieves a value of 0.5. And so the total Gini impurity in this case becomes 0.429, which is 6 by 7, because this is anyway 0, so we don't need to talk about this, we just talk about this. There are 6 points here, and 6 by 7 into 0.5 gives you 0.429. Okay.
Sorry to ask you, but this is for age less than 9.5.
This is for age less than 9.5, correct.
So why are we considering the other yeses?
Where are we considering the other yeses?
He wanted to ask about the false. False
3 yeses in the right hand side.
Yeah,
yeses
see, age is less than 9.5 gives you the first row, because that is true. So true goes to the left hand side.
Okay, it's false.
Yeah, when it is false, it goes to the right hand side. So all the 6 columns. Okay.
Thank you.
Yeah.
Thanks.
Yeah. Okay. So.
Yeah. One more thing. You were saying that Gini index should be less. Value should be less. No? Then only we'll consider that node is pure or not.
Correct. Yes.
Or what is the range of the Gini index that should be considered?
In this case, the maximum value, the minimum value can be 0, as you saw, and the maximum value is actually here. It is 0.5. It depends on the number of classes, but if you are 2 class classification of yes and no, then the maximum value can go up to 0.5. Okay.
I do have one question.
Yeah. There is a sound from somebody. I am unable to.
Yep.
Hello.
Yep. This is Prabhakar this side. So I have one question. Just like, how do you take a decision that I have to consider 9.5 as a decision?
Yeah. So that is a convention that I talked about. Like when you have a numerical feature. When you have numerical features like 7, 12, 18, so one convention is to take the midpoint of all these values and take a yes no true false decision based on that.
Okay.
So 9.5
is the midpoint of all these.
9.5 is the midpoint of the first 2, 7 and 12.
Okay,
got it. Yeah. So the next slide is precisely that. So if you see, the first is age of less than 9.5, which is the midpoint of 7 and 12, and total Gini impurity is 0.429. Then we take the midpoint of 12 and 18, and we do the same thing like we did for 9.5, and if you calculate, that comes out to be 0.343. So the midpoint of 12 and 18 is 15. Then 18 and 35 gives you 0.476. 35 and 38 gives you 0.476, 38 and 50 gives you 0.343, and 50 and 83 gives you 0.429. So these are the 1, 2, 3, 4, 5, 6 different splits that you can take, that you can do based on the value of age, and depending on that you are getting 6 different Gini impurity values. Now somebody please tell me which age or which of these 6 bars should I choose if I have to split based on age.
26
probability 4.76.
I'm not. Can somebody say?
Which one has a less probability? 0.343.
0.343 somebody said. I also heard somebody say 0.476.
Yes, they are more in quantity. Twice it is occurring.
No, see, the way you decide on a particular, as I said, your aim is to create a pure node. Okay, you are creating the decision tree so that you create a pure node, and Gini impurity is an index of, as the name suggests, Gini impurity is an index of impurity. So if you are very impure, then you don't want to go towards that direction, you want to go towards a pure direction. So in this case, the Gini impurity is lowest for age less than 15 and age less than 44. So any two of these you can take. Okay. So did I make myself clear? The one who somebody said 0.476. Do you have any doubts in mind? Why?
No, I got it, sir. Okay.
Yeah.
I
Okay.
think.
Okay, this is, remember, this is the only thing that you basically need to remember in decision trees. Like at every point you are trying to create a node which is towards pure, so as pure as possible, because as soon as you get a pure node, that means you are done, your decision is taken at that particular leaf. So that is why you want the Gini impurity to reduce, you want to split on a feature which will reduce your Gini impurity. Yeah, so okay, so as somebody said, these are the two possible candidates that I have for age of because they are the lowest Gini impurity. So Gini impurity for Love's Titanic is 0.405, Gini impurity for Love's Lord of the Rings is 0.214, and Gini impurity for age is 0.343. These are the values that we all computed. Okay, so now what should be my root node? That's the question that I started with. So now I have done all the calculations. What should be my root node? Can somebody
Lord
say?
of the Rings path.
Correct,
Of their
because it's
Lord
the
of the
lowest Gini impurity. Okay, so that is the Love's Lord of the Rings. If I so now my root is decided. So I have two possible options. It is either true or false. So if it is true, then I have 4 such points. If it is false, then I have 3 such points. Okay, now I have done something like I have already selected the root of my tree. Which of this okay, now let me ask one question, like which of these two green boxes that I have should I split further, or should I split both of them, or should I split neither of them, or should I split or should I split only one of them? Which one should I
You
split?
should
Right side
split.
should be selected.
Which one?
Right side.
Can you give the false or true? Which one?
False.
Why?
Because it is a pure leaf.
Okay, so if you for example, correct, so let's say if you have a pure leaf here, why will you take a decision again based on the pure leaf? I mean why will you split it again? What do you have to gain from that?
It will be an end node, no? Then it is a pure node.
So okay, so let me ask it another way. So why did we select the root node in the first place? Why are we splitting the particular what should I say, splitting the data set into two halves at the root node? Why are we doing that?
To reach to the appropriate conclusion.
Correct. So here if you see at the right, if you look at the right node, do we have something more to conclude, or have we already concluded?
Concluded.
So should we split it, or should we keep it as it is?
Not
No,
required.
no.
Keep it as
Left
it
should be.
Correct. So am I clear, or because see, this is the first time that you are looking at this, so there are bound to be confusions. So if there are confusions, you can let me know now itself. So can somebody say why? Can somebody who had said that we should split the right node, are you sure now why we shouldn't split the right node and go for the left node splitting?
Yeah, I'm clear now. Because right node is already we have the decision.
Correct.
And left side still we have the probability to make the decision.
Correct. That's the perfect answer. So we don't split the right node any further, we split only the left node. So left node, there are only 2 columns remaining, because we have already taken the decision of Love's Lord of the Rings, so we don't have this column anymore. So we only have 2 columns of Love's Titanic and age. So I will not go through that entire exercise again. So let's say I am splitting the left node into Love's Titanic of true and false. So that becomes the okay. So let me ask you again, what should be the Gini index of Love's of the bottommost left node? Can some
0.5,
and the right node?
0.
Yes,
Zero.
correct. So so that is the Love's Titanic tree, you know. So if we split on Love's Titanic, this will be the tree that we have. And if we split on age, so right now how do I select on how does this value of 12.5 come? So if you see, Love's Lord of the Rings has this first column, the third column, the first row, the third row, fourth and the fifth row. So these are the 4 rows that I am concerned about now, and I am taking an average of 7 and 18, which is 12.5. So I am taking an age of less than 12.5 and saying that and loves Lord of the Rings, and this is only one person, so he or she doesn't love Harry Potter, and false becomes loves Harry Potter, yes is 3 and no is 0. What is the Gini index of this particular of these two nodes?
Both 0.
Zero.
Both 0, right? So when we are splitting based on age, we are getting a Gini impurity index of 0. But when we are splitting based on Love's Titanic, we are getting a non-zero Gini impurity because of yes no, because of this particular left node, because it is 0.5, which is why which is why we now split. So this is the final tree that you are talking about, that we have decided. Now here there is one more question is, you see this particular leaf that we have here, it has only one person in here, right? There is only one person, and so there is a person who loves Lord of the Rings, and his or her age is less than 12.5, but there is only one person in the entire training set. So and you are taking a decision based on that. So taking such decisions might be very risky, because you have not seen enough of these examples. You have not seen enough examples of people who loves Lord of the Rings and whose age is less than 12.5, and hence this probably is showing something this is probably overfitting to our training data. This is what is known as overfitting. Okay. Yeah.
Samir, can you come again? Why your selected age is less than 12.5?
Yeah, so if you okay, so if you see here, so you are in the left part of the tree right now, which means that the person loves Lord of the Rings. So there are 4 such rows: the first row, the third row, the fourth row and the fifth row, correct? Can you see that I am talking about the first, third, fourth and fifth rows now? Because
Yes.
and so I am trying to split on age, and as I said, for numerical features you have to take an average of the 2 data points that you are concerned about. So here the first and third age is 7 and 18, the average of which is 12.5, and if you take an age of less than 12.5, you are getting a Gini impurity index of 0, so you don't need to look at the other splits anyway.
All right, I got it.
Okay, yeah, but this is a case where it shows overfitting, because you are not seeing enough examples of which comes into this particular node, and therefore you are taking a decision based on just one example in the training data, which is now this is an indication that you are overfitting to the data, and which is why it's better to not grow the tree anymore. So I had talked about that, okay, at this stage let's grow the left part of the tree a bit more, one more level, but it's better to not grow the tree any further, because here anyway, if you come to this particular node, you are 75% sure that you are taking the correct answer, you are predicting it correctly. So you don't need to grow it any further, you just stop the tree at this particular stage. Okay.
So may one question.
Yeah.
If we take the average of third and fourth, that is 18 and 35.
18 and 35, yes.
Then we'll have 2 probability on the left side, 2 yes.
If you are taking an average of 18 and 35,
yeah,
then it will be like there will be 1 no, 1 yes, and 2 yes on the other side. Yes, correct.
So how to decide to take whether 12.5 or average
See,
of
if you
18?
have one no and one yes, that means your Gini impurity index is non-zero, correct?
Yes.
So that means it will be more than 0. And anyway, Gini impurity index cannot be less than 0. Therefore, if you achieve for any one particular split, if you already achieve a Gini impurity index of 0, that means you cannot, so that is a good split. Any other split can also give a Gini impurity index of 0, but it won't be better than than this particular split, correct?
Yeah.
That is why the first try that you take of 7 and 18 itself gives you a Gini index of 0, which that is why you go along with that, you don't even look at the other splits. Okay.
Okay.
Yeah. Oh,
But if
yeah.
the data set is too big, calculation like this manually will
See,
be very
finally
tedious.
you won't be calculating any of these. Finally you will take some tools which will calculate all of these things for you, and I hope I have time to show that example. So I am just showing this is a toy example just to show about how things are done, so that you know that what are the different things that are there in the toolbox that you are going to use. Okay.
Yeah.
So this is just a
Yeah.
toy example, and mostly in exams also, if you are given this sort of calculation, you will be given this sort of examples only. You won't be given big examples with many features. Okay. So that is
So,
one. Yeah. Yeah.
with the again overfitting, what is overfitting and how it shows the overfitting?
Yeah, so overfitting is like in this example, if you see, you are taking a decision based on just one training point out of 7 training points. If you are taking a decision based on that, first of all, 7 training points is anyway very less. But for this toy example also, you are just taking a decision based on one training point. That means that you have seen a person who loves Lord of the Rings and whose age is less than 12.5 only once in the entire training data. So when the test data comes, you are not for example, if you look if you ask a single child in this entire world whether he or she loves Lord of the Rings, and his age is, let's say, less than 12.5, and he or she says that she doesn't love Harry Potter, you cannot ask just one child and say that this will be true for all children in the world, correct? So,
Okay.
so you cannot you are not generalizing in that case. So only if you see a large number of examples will you be able to generalize. So one here is very strange because the number of trading points itself is 7. See, the other nodes that you are taking is looking at 50% of the data roughly. It is looking at 3 data points. This is also looking at 3 data points. This is also looking at 3 data points. So that is still fine, but this is looking at just one data point. So you cannot hope to generalize by asking one person. You cannot hope to generalize to the entire world. So that is why this is probably showing overfitting. So keep it at that. Better to not grow the tree any further. You know that you have some probability, you have a probability of say 25% cases you will probably predict incorrectly, but we can live with that 25% chance is something that we have to live with, and because 75% of the cases we will be correct. So anybody who goes to the left branch is predicted to love Harry Potter, because 75% of the cases in this particular branch love Harry Potter. So that is it. That is the classification tree that we are talking about. Decision trees can be used for regression. I have not talked about that. It's a bit it's slightly different, and I don't want to talk to it about also now because I have the program to show. So basically it's like split on a particular variable and assign points the average value of all points in that class. So it's a bit confusing from this thing, but okay, so I'll skip this because it doesn't make sense to talk about decision trees for regression. So do I have any questions about decision tree for classification? Else I'll go to the program. Hello? Anybody?
No doubt, no doubt.
No doubt.
No showman, no doubt.
Okay. Let me try to present my screen. Try to present my other screen. I hope it works. Yeah, can you see a code or something, or
Yeah, not yet.
Not yet.
Not yet.
not yet? Right. I don't know how to make
A
this.
black screen, not yet.
I don't know how to make this work also. Let me see. I'll stop presenting again. How to make this work? Let me see. I don't know whether this will work.
Soumya,
Yeah.
please turn off the cameras so that your presentation will be visible immediately. Otherwise, it will eat up the bandwidth and. Okay.
No, my camera is
Good.
already on, I guess.
No, I'm telling that turn off the camera, so it will speed up the process.
Okay. I'll actually I have. How can I show this?
Is it a Python code?
Yeah, it's actually online, so that is why I am having a bit of a difficulty in showing this. Just a minute, I don't have the data also. Let me try to do one thing. Just give me 5 seconds. I'll try to
There
figure
is an
some.
option your entire screen.
Entire screen doesn't work in my computer actually. I don't know why, but it doesn't work. So I'm trying to do something else. Just give me 5 minutes. I'll try to figure something out. Why is this not getting? Okay. Downloads decision tree. It's not even up. Okay. Good.
Yes, so maybe we can see your screen
You
and
can
code also.
yeah, you can see my screen, right? Okay. So
Right.
Yeah, I can
okay.
see.
Yeah. So okay. Let me connect. I don't know whether I will be able to explain the code completely, but I'll give you a brief overview about how to go about this in Python. So this is Google Colab. So if you don't know, this is like Google itself provides it through your Gmail account, and you will be able to do machine learning coding through this. So let me Net is not very fast. Okay, so these are the different packages that so if you don't have any exposure to Python, then basically it's like you are trying to import different packages which we will be using for your code. Pandas is a very important package, like it's like it helps us work with tabular data. NumPy is the numerical Python package, and matplotlib is for plotting. sklearn is the scikit-learn, it stands for scikit-learn. So scikit-learn, if you have machine learning, normal machine learning stuff that you want to do except deep learning, or some basic aspects of deep learning also, you can do it using scikit-learn. If you see here, the first scikit-learn package that you guys can see my cursor, right, what I'm highlighting?
Yeah, I can see.
Yeah.
Correct. Okay.
Yes.
So if you look at the first point that I've highlighted here, it's a decision tree classifier. So I will classify using a decision tree. The second one is how to plot a tree. Okay, the plot itself will not be visible, but anyway, I'll just show you how to plot one. Then train test split is something, if you get a set of data, if you get the data points, then you try to split it into your train and testing splits. And the different metrics, I will talk about the metrics as I use them. So I will run this, I will import all the packages. This is the location from where I have downloaded this particular data set, the one which is commented out in green, and I have kept it in my Google Drive. So let me try to load it. I think this, I have to do this. I hope it works. First try. Okay, so the data, I have loaded out the data. So it's a data based on heart disease. So you are trying to predict whether a person with some particular health parameters has a heart disease or not. So that is the question that you are asking. So let us look at the first 5 rows of the data. So df.head, whenever you do this, it will give you the first 5 rows. If you do df.head 10, it will give you the top 10 rows. Okay, so that is how so I will do df.head again, so otherwise see okay, so these are so there are 14 such columns, and these are the different values. We don't know what these values are. So if you go to this particular website that I have linked in the top, there they have mentioned the different things that are the different column names basically. So there are different parameters, like CP is there. So first the first column is index. I guess the first column is index, or no, sorry, first column is age. The 0, the column that is starting with 0, that is age. This is the gender of a person, and so on. So I will talk about this. So first is age, and then is sex. So sex means gender of the person. 1 is for male, 0 is for female, and so on. The other columns are as follows, like chest pain. There are 4 different values of chest pain that can be there. So these are all, as I talked about in the last lecture, so these are all categorical variables. There are 4 such values that you have. Then rest BP is a resting blood pressure, it's a real value. Cholesterol, then FBS is a fasting blood sugar, whether you have blood sugar or not. Similarly, a 1 and 0. Rest ECG, again this is a categorical variable, different parameters. I am not going into the details because we are not talking about the medical side of this, and so on. So there is a mixture of categorical variables, there is a mixture of categorical real variables, and so on. Okay, so what I do is, depending on these different things, in order to give it a more meaningful name, I rename all these columns, like age, sex, CP, rest, BP, and so on. So if you now see the same tabular thing which was which was like this, has now the column names have been replaced like all these. Okay, so that is the thing. And then what we do is we do a df. Okay, and then we do a df.d types. By this, what we try to do is we try to get a data type of all the different of that particular column. So if you see age is float 64, sex is float 64, and so on, we see two such columns which I am highlighting here, which is CA and THAL. If you see CA and THAL, they are like yeah, CA is number of major vessels 0 to 3 colored by fluoroscopy, and THAL is 3, 6 and 7, which means that these also should have been float 64 objects or float 64 data types, but they are given the data type of object by pandas, which means that CA and THAL we need to investigate. So let us go, the way you select a particular column is by this in pandas. You take the df, you put a square third bracket and you put the name of that column in quotes in that, and you will get that particular column, and you find out the number of unique elements which are there in CA. And you see there is 0, there is 3, there is 2, 1, which is what you expect, right? CA is 0 to 3. So there is 0, 1, 2, 3, 0, 1, 2, 3, except that there is also a question mark. Can everybody see the question mark?
Yes.
Yes.
We can see.
Yes.
Similarly, if you have df thal, then also you see there is 3, 6 and 7 are values which you expect, but there is also a question mark in this, and because of this question mark this became object. This could not be converted to float 64 because question mark is something which you can't convert to a floating point number. So you find, so this question mark is probably giving you an indication that these are the missing values in that particular data set. These are the values which are not present in that particular data set. So the way you find out this is given by this command. So you so basically what you are trying to find out is the number of such missing values. So df.log is, you will find out that column, find out that row where the column value of this CA is equal to question mark, and this is a OR df thal is equal to a question mark, and you take a length of that. You see that there are 6 such rows which have missing values. You try to print out those rows in the next. Okay, I am not running them for some reason. Let me run them, otherwise later I will face a problem. Okay, 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 okay. Yeah, so these are the 6 rows that have missing values of CA or THAL, and if you see in each of these 6 rows, either one of them is missing. So the first row THAL is missing, the second, third and the last 2 rows CA is missing, and again this 4th row THAL is missing. So we find out the length, the total number of data points in our particular data set, which is 303. And since there are only 6 rows which are missing values, we remove those rows completely. This is one way of, this is a very naive way of dealing with missing data. One more thing which you can do is you can take the maximum number. So you can, there is a technique called imputation. I didn't want to go into that because that is not covered in this, but there is something called imputation, in which what you can do is you can take the maximum the most frequently occurring value for CA and fill up this question mark with those value, with that particular value. That is called mode, that is
Mode
called mode, yeah, the mode. So that is called mode imputation. Similarly, you can do the same thing for THAL. One more thing which you can do is you can arrange them in a sorted way and take the median value of this particular column and fill up these missing values with those with the median value. So that is called median imputation. These are all categorical variables, so mean imputation is not possible for any real value. If you have a missing value for any real column, if you have a missing value, then one thing which you can do is you can take the mean of all the values which you have recorded and impute the missing values with that mean. That is called mean imputation. So I am not doing any sort of imputation here. What I am doing is I am simply I am simply removing the rows which are there, which are missing values. Okay, so TF no missing, this particular thing will now have a length of 297, because I had initially at 303, I have removed 6 rows, so 297 rows are remaining. And just to check, let me check the value of thal. You see that question mark is not there anymore. Okay, so now what we need to do is we need to get on with the X, or the features, and the predict and the label. So X is the, so we the final column in this particular data set was HD, which means heart disease, and so I remove that. So drop means remove, and it will now have all the other columns except the heart disease column. Similarly, I put the heart disease column into Y. Okay, and I see the X dot D type just to check. C and thal are still objects, which is fine, but they don't have any missing elements in them. Now chest pain. See, now the other important thing is, like last day there were many questions on what are categorical and ordinal variables. So this is a perfect example of that. Like these are all categorical variables 1, 2, 3 and 4. But if you treat them in an ordinal way, which means that like 1 is greater than 1 is less than 2 in some sense, 2 is less than 3 in some sense, and 3 is less than 4 in some sense, which means that you are seeing that asymptomatic is getting the highest value and typical angina, which is a bad thing, is getting the lowest value. You don't want any of this sort, any sort of these ordering to happen, which is why what you do is, this is a very simple trick which is available in pandas. So what you do is you do get dummies, and you take X and you put a columns and this column will specify which particular column of the original data set you want to get a dummy for. So if you see, originally there was CP only one column. Now if you see the last 4 columns, CP has been set up into 4, CP has been separated out into 4 columns, and wherever the value of CP was 1, it has been given a value of it. So CP 1.0 has got that value of 1, all the others are 0. Wherever the value of CP was 2, there CP 2.0 is getting a value of 1, all the others are 0, and so on. Is this clear to everybody?
This get them is it one hot encoding like?
Yeah, exactly. This is exactly what one hot encoding is. So one hot encoding you can do in multiple ways. pd.getDummies does it in one step for you. Okay. So these are the 4 categorical variables. I have already looked at the data set and I know that these are the categorical variables. If you are working on a new data set, then you will have to find out the categorical variables yourself, and I do a pd.getDummies on all of these columns. So if you see, CP1 has become CP has become CP1 to CP4, rest ECG has become 0, 1, 2 and so on, slope has become 1, 2, 3 and so on. So now if you and you take a unique value of Y. So finally you want to do a binary classification. So 0, 2, 1, 3, 4 are different stages of heart disease. So what you do here is, except for 0, everything else is heart disease. So all non-zero values mean heart disease, and you do this by this particular cell. So you first select all the indices where Y is greater than 0, and you assign 1 to all of them. So finally your classification becomes a binary classification. So now your data set is created. You create a train set and a test set out of that using this particular line. So you train test split, which I had imported from scikit-learn. I will pass a X encoded. This is the features, this is the labels, and this is the random state. So random state because you want to run it from multiple seeds maybe, which is why you can omit this random state also, it doesn't matter. So train test split X encoded, and it will give out an X train, a X test, a Y train and a Y test. So this is the first step. The next step is to create a decision tree classifier. So right now what I have created is a decision tree classifier which is random state of 42. All the randomizations will be according to that seed of 42. The max depth is 4, which is why I mean from the leaf to the lowest, from the root to the lowest leaf, you will find a maximum of 4 branches or 4 such arrows. That is what is meant by maximum depth of 4, and maximum features of log 2, which means that if you have a total of, let's say, 64 features, when you are trying to, as I showed in my slides, the maximum number of features that you will take at any point of time to find out the best split will be dependent on log 2 of 64. So that is what max features means. And so CLF dt is CLF dt dot fit x train y train, pretty simple. Okay, and so finally you create a class name. So you have already trained the tree at this particular point. When you are saying CLF dt dot fit x train of y train, you have already fit the tree. Now you want to see the tree. So let's see how the tree looks. This is how, see, so this is how the tree is looking. Can everybody see the tree? It's looking very small, but can you have some?
Yes.
See, so this is the root node that we are talking about. CA is less than 0.5. Then we are going down here, and so it's so this is how finally all the calculations have been done by scikit-learn, and they have created the tree for you. And if you see, at any point of time, I mean through all the nodes, there is a maximum depth of 4 from the root to the leaf. Okay, so finally the confusion matrix. So this is the confusion matrix that you are having. This is the true label on the left hand side, and this is the predicted label. So you had correctly predicted, so this is the true positive. Okay, so now somebody tell me what is the true positive in this case. If my heart disease prediction is my aim, what is the number of true positives from this confusion matrix? Can you tell me the number of true positives?
Saying 22 are true positives, no? Which
Correct.
are having heart.
Correct. And what are the false positives?
11.
8, I guess. 8.
Correct, good. So that means you have got hold of this metric thing at least. So accuracy score is something that you predict, it's 75%. F1 score is again a harmonic mean of precision and recall. So let's see the precision score.
So F1 score is important here.
F1 score is not very important here. I just showed it just to show that accuracy and F1 score are pretty easy to compute. It's not very important here because the problem is more or less balanced. Okay. I mean, if you see, the accuracy and F1 score are nearly close to each other, are not quite different. One is 70, one is 75. So you can work with both of them. Okay, so precision score is 73, which is true positives by true positives plus false positives, and recall score, I don't know what, it's 67%, which is true positives by true positives plus I think false negatives, I think. Yeah. Okay, so
in which applications F1 score is a
F1 score is
value?
F1 score will have a great value in this application itself if in your particular data set the number of no heart disease examples is much more than number of yes heart diseases. Okay. In that case, even if you predict everyone to be healthy, even then your accuracy will be very high. But it may not be, it is not the case in this particular data set because they are more or less balanced. F1 score plays a very important role whenever your data set is imbalanced towards one particular class. Okay, so now here if we see, the training accuracy is also not very high. So let me try to increase the max depth at this particular stage, and I make it 8, let's say. And it has again trained something. Let me see, the tree now will be completely, you won't be able to understand anything from the tree, but see, this is the tree. See, the depth here is 8. If you calculate, there will be 8 rows from the leaf, from the root to the leaves. Now let's see, I guess it's much better now, but let me see the different metrics. So earlier it was 75% accuracy, it has now gone up to 85%. So this is definitely better. F1 score was 70%, it has gone up to 82%. Precision, I forgot the last value, it has now almost, it is almost now 90%, and recall has increased from 67% to 75%, which means this is a better tree. Okay, now let me try to increase the number of the maximum depth to 16.
How you are deciding the depth number?
I'm just working out, I'm just looking at the test accuracy and deciding on the test on the depth basically.
Should we take depth in terms of 2 power or any one?
Any one, right? Let me see, let me make it 12.
Is there any function to find out the optimum depth number?
That will depend on your cross validation, but here I have the data set is itself very small, so I have so basically if you have some test data that is given to you by others, then you can keep out a part of your training data itself as your validation data, like I have done. So in this case I don't know what test data I have to work on, so I have separated out a training data into the validation data myself, and I am taking my decision based on the performance of the validation data. So this X test is basically X val, if you can consider that. Okay, did I make sense, or?
Yes, we got the point.
Yeah.
Awesome session.
Okay, so after this, so now I have increased the data points to 12, the maximum depth to 12, which is why the tree has become completely impossible to understand. Anyway, so let me see the accuracy. The accuracy earlier was 85%, if you can see that. You guys can see this 85%, right?
Yeah.
Okay, so let me see the accuracy now. See, the accuracy has come down to 72%, which means that you are starting to overfit on the training data. For the data that you have not seen, your accuracy is coming down. F1 score will also come down from 82% to 68%. So it's worse than what so I could achieve an accuracy of 75% if I am not mistaken, with a maximum depth of 4. With a maximum depth of 12, I am performing even worse. And precision score from 90% is come down to 69%, and recall score has come down 76 to 66, which means that you are performing worse, and which this means that you are overfitting on the training data. Okay, so did everybody understand that this is an example of overfitting, or do I need to explain it a bit more?
Is there any learning rate parameter also there?
No, learning rate is not there, because this is not like linear regression or many other things you will learn in this course. Except for decision trees, everyone has that gradient descent and learning rate parameter. Gradient descent or decision tree doesn't have that parameter here. Decision tree has this max depth, max features. There are some more parameters, but I have not included them. These are the parameters that you work with in a decision tree. Okay, so
here random state is taken as a 42. Why it is taken as a 42?
you can take any other random state also, like you can take 1 2 3 4.
So what is the difference that is created by random state?
It's like a different split will be created. Like here, if you have a train test split, what it does is, if you have 300 rows, it will randomly select some percentage of the rows, some percentages of the rows into the training set and the test set. Okay. So the default value I think is 0.1 or something, maybe no, 0.25, so 25%, 0.25 or 0.22 or 0.25 something. So I have forgotten the default value. Anyway, so that default value we will create and we will put it into train and test, and so depending on different random states you will have different splits of train and test. Okay, since somebody said Let me try with the random state of 1 2 3 4.
So here we have only 300 data. So how can we take 1, 2, 3, 4?
1 2 3 4 is a random seed.
It's a seed value.
It's a seed value. Depending on the seed value, you will select 20% of your total. So let's say if you have 100 rows, you can
Yes.
select 20 rows in 100 C20 ways, correct?
So can we go with the cross validation instead of test trend split?
Trains, yeah, cross validation also you can go, but in this case I have not, I just wanted to show a very simple example. If you don't have so cross validation is actually the thing that you should use for designing on the different hyperparameters, but again I did not want to go into that complexity, and hence I did a very simple split of this.
So in
Okay.
terms of hyperparameter tuning only, we should go with cross validation.
Cross validation, yes, you should always go with cross validation when you are doing hyperparameter tuning. I mean, this is so this is one such one direction, like you can split 20% of the data in 5 different ways and see the average accuracy on that on that 20% of the data for the 5 different seeds, and take a decision based on that. That is also cross validation in some sense.
But you have not mentioned any split value here.
So split
yeah.
value, I have kept the default value. Let's see what is the default value of split. I think it's 0.2 or 0.25 something. Parameters, arrays, if test size, if
0.25.
it's 0.25. So 25% of your data will be split into the, will be put into the training data. And let me also check one thing. Len of y test, it should come out to be 75. Yeah, so so you had 297 points, 25% of that is 75. So that means that you are testing on a separate set of 75 points for this particular random seed. So you can set 5 random seeds split on 5 different values, and you can, or you can, what you can do is you can choose the first 75 points for your test set and do it 4 times, and finally get the result as an average of the accuracy of those 4 such runs, and you can set your maximum depth based on that. That is also possible. So there are many ways to do this. I think sklearn or scikit-learn already has something which does the cross validation for you itself. So yeah, you can choose the maximum depth based on that. I mean, you should choose the maximum depth based on that. Okay, so I just wanted to show a very small example that how overfitting occurs. So yeah, I did not run this. Let me run this and see what is the accuracy. Okay, earlier my accuracy was how much? Does somebody remember with 8? What was it?
85.
Okay, let's see. It's much less. It's much less for this particular data split. Have I done something wrong, or shouldn't be this less, right? Why it is this less? 1 2 3 4 5 6 7 8, correct? This is quite less. I did not expect this. Anyway, it is much less. Anyway, so for this particular, so this is why probably you should go for cross validation, because for this particular split 8 is not doing very well. So that is why maybe
I think 4 is the best value.
Maybe. So I don't know. I mean, it depends on the final cross validation answers also. So you will take an average.
Is it the effect of random state?
It's an effect. It's actually an effect of random seed, because what you are doing is you are training on different data and you are testing on a different set of data. So depending on that, your training and testing distributions might also change. So that is why this might be happening. So that is
So
why
how
you,
can we decide this random seed?
you don't need to decide on
In
the random seed. What you need to do is, in normal machine learning terms, what is done is, so cross validation is performed. So cross validation is performed means you take 20% of your data, you split your data into 5 groups of 20%, and you train on the, and so you train your model 5 times and test on the
Okay.
remaining, and you take the average of it, and whatever hyperparameter gives you the best result, based on that you choose your hyperparameter. You don't depend on the seed in that case.
Okay.
Okay. So I just
Right.
showed the seed here because I wanted to give a train test split and wanted to do that, but you can choose a different hyperparameter completely.
One
In
question, Somya, can we
Yeah.
similar,
give max depth as an array, changing from let's
No,
say
no, no,
assume
no,
4 to 12?
that it won't allow. So you can run that in a loop and do that.
And
Okay.
then check all the values for the array, and which one is giving the best one,
Best, huh?
that one we can say the optimum value.
Yes, correct. See, in this case 4 is giving much better than 8. So so it depends. So that is the thing, like, so what I wanted to drive home with this particular example was, maximum depth is something that you need to check carefully based on the validation data, and it's not like if you fit very well on the training data, your maximum depth will, or your generalization will be very good, because then you will start overfitting. So that is the major point that I wanted to drive home. I hope everybody got some idea about that example. So do you have any
Could you
doubts?
could you show me the underfitting as well?
Yeah, underfitting, like if you just have, let's say, 1 maximum depth. I hope it doesn't give error, but yeah.
Considering accuracy, but it in classifier it doesn't matter accuracy. It your precision and recall matters a lot.
So everything will reduce. See, accuracy score is actually 72. It's not very bad, but F1 score is quite bad in this case. So F1 score is the lowest of 0.64%. So precision has gone down, recall will also go down in this case. So yeah, recall has gone down to 55%, because this the number of false negatives has increased a lot. So this is
Can
a,
you quickly summarize those last 4 parameter and its significance?
yeah, so accuracy is accuracy is basically number of things that you get correctly in your entire data. It is true positive plus true negatives divided by true positive plus true negative, divided by everything, basically true positive plus true negatives by the total number of samples in your entire data set. F1 score I am coming to later. Precision score is true positive by true positive plus false positive, which means that out of the total number of positives that you predicted, how many in how many were you precise, which is why it is called precision score, in how many were you precise. And recall is true positive by true positive plus false negative, which means that out of how many positives in the entire data set could you recall them to be correctly positive. So that is why it is called recall, true positives by true positives plus false negatives. So that is the precision and recall, and the harmonic mean of precision and recall is F1 score. Okay.
Okay,
Uh,
thank you.
and what is harmonic mean?
Harmonic mean is, if the harmonic mean of precision and recall is, if you denote them by P and R, then it will be 2PR by P plus R. So that is the harmonic mean of, harmonic mean of any number is 2AB by A plus B. So harmonic mean of precision and recall is F1 score.
Could you share the link of this notebook in
Yeah,
chat box?
I'll okay, this notebook in chat box. Okay, I'll share this one maybe. This one is probably better. Just a minute. Just give me a minute. I'll share. This probably won't work for you guys because you would need to download this data, but that data is already there. I mean that link is already there in the this thing. Yeah, I have shared it, so you can have a look at this, and you can I don't want you to copy directly from this particular notebook. What I want you to do is look at this and then do it yourself, because that will give you a feel about how to. For example, missing data is something that you really need to look at when you are actually doing a machine learning project. So missing data is something that you need to look at. See, the another very interesting thing is, like, doing the machine learning thing was basically 3 lines. Before that, all these lines were just processing the data. So data processing is something that you need to learn, and you also need to love it. Otherwise, this machine learning thing is just 3 lines, so it is nothing basically. Anybody can do this. All these different sort of tricks, like how to replace the missing data, I did not show that, but you can learn it yourself. That is called imputation. So how to do data imputation, you can do that. You can search in search in Google and learn that also, and then you will have a feel about how to go about this machine learning different projects. I have shared that link in the chat box, so you can.
I copied it.
Yeah. Okay.
Thank you so much. It's a very nice session.
Sorry to interrupt. Like it's asking about the request access to the link.
Yeah, you don't require request access for that, right? You can just you can scroll through the notebook, right? Can you scroll through the notebook, or they are not allowing to open also?
So we are not. It's not opening.
Okay.
Well, I think request access is asking.
Okay, okay, it's ask you're not okay. I will provide the request access in some time.
Thanks for support.
I'll provide. Just a minute. General access. The link. Yeah, I'm pasting one more link. Can you check now?
Just wait. Now it is accessible.
Okay, good. You go through this link. Okay, I'll stop sharing this tab. Okay, yeah, so yeah, you go through this link, and it should work out. If you have any problems, then I mean, it should work out. There shouldn't be any problems. And yeah, so in this lecture we talked about how to create a simple decision tree using my slides, and then I showed you a program. I hope you have some idea about how decision tree works and how they are coded in Python. So yeah, if you don't have any questions, then I'll close this meeting.
Thank you so much.
Thank you.
See you in the next Saturday.
Sure.
Thank you so much. Thank you. Thanks a lot.
Okay, thanks everyone. Bye.